So some of you crazy people did want to know more about PSFs and how they can evolve to form images, so I'm gonna do my best. Also, just note how beautiful is this view out of my window right now. Yes, that is the sun setting over the Pacific Ocean. Crazy. Okay, so the fact of the matter is an image is never a perfect representation of reality. So the reason that stars have diffraction spikes and galaxies don't is because stars are point sources. That means in reality, they are occupying one slot, one pixel of what is happening in your reality of the sky, one pixel. However, when the light passes through the optics of your telescope, it's affected by the telescope. That's inevitable. You literally can't stop this. Even if you had a perfect aperture, you would still get something called an airy disk, which looks like this and is basically like the most idealized PSF you can get. When you have more complicated apertures, this PSF gets more complicated, and that's why we get things like diffraction spikes. The diffraction here is the same kind of diffraction that water has. It's just because light is a wave and it diffracts. So how do the reality and the PSF interact to form an image? Well, they are convolved together. And if you're not familiar with convolution, I don't find this to be a very intuitive concept. I think it's a little easier to see an example. So I'm going to do 1D because I think it's a little bit easier to parse. But so now we have our delta function here. So we have this one single pixel that has a value. Everything else is 0. And we have our perfectly idealized airy disk PSF here. So as we slide the PSF across the window of the image, we're going to multiply that by the image values and then sum it up to get one single point in your convolution. And so as you slide it, you're building up this convolution. And as you can see, since you're mostly multiplying by 0 because the delta function is 0 everywhere except that one single value, you're mostly going to get 0 until the PSF starts to kind of appear there. And so you're basically just recreating your PSF. You end up getting whatever your PSF is, affected by the resolution of your telescope. So what happens if the source is no longer a point source? So that is what we call an extended source. And that means that in reality, so not in the image necessarily, but in reality on the sky, the thing that you were wanting to take an image of occupies more than one pixel. This is considered a resolved object because your resolution is high enough that you have multiple pixels, basically, that would be able to see this object. So now when you do the convolution with the PSF, because it's not 0 everywhere, you're getting more values that are kind of smushed together. That's the official term. And it basically kind of smooths out that very characteristic airy disk structure, and so you don't really see it anymore. And so that's exactly what's happening with galaxies. The diffraction spikes kind of disappear because they're basically being smooshed out over the whole extended object. They're not all happening at the same spot like they are for a point source, and so you don't see those beautiful diffraction spikes for galaxies.